Hey everyone, welcome to our video on gas liquid separation processes. My name is Zulfi,
My name is Mantang.
My name is Adam.
and today we're diving into one of the most common ones, absorption. Absorption might sound complicated, but it's actually all around us. Whenever a gas dissolves into liquid, like how carbon dioxide dissolves into soft drinks, or when water absorbs ammonia gas in industrial plants, that's absorption happening. In industries, this process is essential for cleaning gas streams, reducing chemicals, and reducing pollution. So let's break it down step by step.
What is absorption? Absorption is a mass transfer operation where a gas mixture containing a solute is contacted with a liquid solvent that selectively absorbs that solute. In the process, the gas mixture usually have two parts. The first part is an inner gas that doesn't react and a solute that's actually been absorbed. The liquid solvent is chosen so that the solvent is solute in it, while the rest of the gas just passes through. For example, removing ammonia from an gas ammonia stream using water as adsorbent. This whole process depends on the difference in concentration between the gas and the liquid. That's what drives the solute to move from one phases to another. Over time, both phases reach equilibrium, where no more mass transfer happens. A principle of the operation. Absorption is typically happens in counter current flow, meaning that the gas goes outward while the liquid flow downward inside a column. That setup gives maximum contact times between the two phases. Uh, Imagine a column where the gas entering from the bottom, bubbling up, and the liquid comes from the top, trickling down. As they meet, the gas loses its soluble component to the liquid. That's the essential of absorption. The relationship between the solute concentration in gas and liquid is described by Henry law, which says the solubility of a gas is in a liquid is directly proportional to its partial pressure. In real life operation, we also use we also need to consider things like temperature, where higher temperature reduce solubility, pressure, where higher pressure increase gas solubility, and the last one, flow rate, where this flow rate is affecting how well gas and liquid interact.
Now let's talk about the equipment used, the real heart of the process. There are two main types, which are the first one, plate or tray towers, and the second one is packed bed towers. The first one is plate towers. These are towers that contain a series of trays or plates stacked on top of each other. Each tray acts as a stage for gas liquid contact. There are a few designs. Sieve tray, the one has holes in the tray, allowing gas to bubble through the liquid. Is cheap and simple, but limited to certain flow rates. Valve, tray- valve tray. This has small lift valves that automatically open or close depending on gas flow. It can handle a wider range of operations and is more flexible. The last one is bubble cap tray. The gas passes through rises and is directed sideways through caps with slits, creating bubbles in the liquid. It's very efficient but also quite expensive. That's why it's less common now. Pack towers. Instead of trays, these towers are filled with packing materials, things like rashing rings, burl sandals, or pal rings. Here's how they work. The liquid is sprayed or distributed at the top, and it flows downward over the surface of the packing. The gas moves upward through the gaps between the packing, creating a large surface area for contact. Pack towers are preferred when low pressure drop is needed, continuous operation is required, or you're dealing with corrosive systems. They also allow higher flow rates and are more energy efficient compared to tray towers. Absorption is used everywhere in the industry. For example, gas purification, removing CO2, SO2, and H2S from exhaust streams, ammonia recovery in fertilizer plants, solvent recovery in chemical production, environmental, environmental control, where harmful gases are captured before they're released to the atmosphere. Basically, if it involves gas cleaning or purification, absorption is a part of it.
Okay, now let's move on to the industrial application. Modern application systems are now smarter and more efficient thanks to technology. Structure packing like Melapart provide higher surface area, better flow uniformity, and lower energy use. CFD modeling, that's computational fluid dynamics, help simulate how gas and liquid move inside towers before they are even built. Membrane assisted membrane assisted absorption combines membrane separation with liquid absorption, offering compact and selective operation. And new solvents like ionic liquids and amine-based solution can absorb gases like CO2 more effectively while being environmentally friendly. All this innovation aims to reduce energy consumption and make gas purification more sustainable. All right, that wraps up our presentation on gas liquid absorption. To sum everything up, absorption is all about transferring a gas solute into a liquid solvent through counter current contact. It is carried out using either tray towers or packed towers, both designed to maximize the interaction between gas and liquid. This process plays a major role in industry that deals with gas treatment and pollution control, helping reduce harmful emission and recover valuable compounds. And with the latest advancement like structure packing, new solvent transformation, and better design models, absorption continues to evolve, becoming more efficient and sustainable for modern industry. So we hope you guys enjoy learning a bit more about how this process works and why it is so important in real industry application.
If you like our presentation, don't forget to drop a like and comment. Your feedback really helps us improve and keeps us motivated. Thanks again for watching and have a great day, everyone.